You may have heard that there are numerous universes in which you exist but live a different life, make different decisions, and culminate a completely different outcome in each universe. The multiverse is what we call it. Where did the concept of numerous universes come from? Have we finally discovered a proof of a parallel universe, or is it something even crazier that we can't explain? Hello and welcome back to the Discover Space channel, where we give you the most intriguing cosmic revelations you won't want to miss. Be sure to subscribe if you haven't already, and join us as we uncover the evidences that just might lead us to answer our questions about parallel universes. The Big Bang, which expanded faster than the speed of light in a growth spurt known as inflation, gave birth to the universe as we know and exist in. And space has been growing for as long as there has been a universe, ever since it began 13.8 billion years ago, and it keeps expanding. Though it is immensely vast, right now the universe is all crammed into a relatively small area of 93 billion light years across. It may be made up of billions of galaxies that are separated by enormous distances, but the observable universe could be finite, or it could go on forever. Either way, matter is arranged in certain patterns in the universe, and there are only so many ways matter can arrange itself in a sphere billions of light years across. Because the observable universe only stretches as far as light has traveled, space-time further than this distance can be thought of as its own universe. And if this is correct, there would be a plethora of universes coexisting in a massive patchwork of realities. Although the concept of parallel universe or a multiverse remains a mystery, with some dismissing it as pure science fiction, it remains as one of the most contentious issues among specialists, with some believing they exist and others saying otherwise. In the well-known double-slit experiment, interference patterns occur when particles pass through two small gaps at the same time. It conforms to wave theory. But wave theory is just one way of looking at light. As it turns out, light can be both a wave and a particle. For example, when some photons pass through both slits at the same time, the interference pattern created by these passing photons is visible on a nearby screen. When a detector is placed in front of each slit, the interference pattern disappears. The standard interference pattern should be created by one photon while the other travels to the detector. But oddly, it didn't work at all, which means that viewing a photon can alter previously occurring events. Parallel worlds are among those inventive notions that are difficult to prove from a physics standpoint. The concept of multiple universes, on the other hand, revealed that the subatomic world is quite hazy. An object resides in one well-defined location in our familiar human-scale reality. For instance, you place your phone down next to you, it will be in the only location it can be, whether or not you're looking for it. Until recently, the behavior of something as fundamental as an electron was thought to be determined by whether or not someone was looking at it. Normally, an electron isn't in a specific location. It exists in many possible locations at once, a phenomenon known as quantum superposition. But when someone looks at an electron or any other object in the quantum realm, its location becomes determined with probability. In 1957, Hugh Everett proposed that all quantum possibilities exist in individual universes. He theorized that all outcomes occur but only one is realized in our universe, and that all other realities split from ours and spawn their own worlds. Along with the idea of multiple universes created by infinitely extending space-time, other universes could also come into existence from a theory called eternal inflation. Eternal inflation theorizes that some pockets of space stop inflating while others continue to inflate, giving the rise to many isolated bubble universes. But on another note, our world could simply be a bubble in a vast sea of space filled with other bubble universes like ours. In string theory and M theory, there are concepts related to brain worlds, parallel universes that exist just beyond our reach, that states that our world may be more than the 3 space dimensions and the time dimension. These 3-dimensional brain worlds could live in a higher dimensional environment. In 2016, NASA used the Antarctic Impulsive Transient Antenna, or ANITA, a helium balloon with an array of radio antennas to detect cosmic ray neutrinos. These ultra-high energy particles are a million times stronger than anything we can make on Earth that could theoretically reach Earth without being weakened. Scientists were surprised when ANITA detected heavier particles called tau neutrinos coming out of the Earth, and if the particles were indeed real, it would mean they'd have been traveling back in time and could be evidence of a parallel universe. But this would also mean that the parallel universe would be running backwards in time. Another evidence would be the cosmic microwave background that fills the known universe. This relic radiation provides a pristine record of our cosmos as it expanded from the beginning. A large, exceptionally cold area in the CMB spans 1.8 billion light-years and emerges in the southern celestial hemisphere. This odd CMB cold patch is colder than average and was assumed to contain less matter than other areas of space. A 2016 academic survey claims that this frigid supervoid is an unnaturally occurring phenomenon. In a separate study, simulations revealed that there was only a 2% chance that the cold spot could have developed. Researchers are considering the possibility that the cold spot was formed when our universe collided with another bubble universe. If this is true, more strange answers may be found. One of these is that the cold spot was created when our universe collided with a bubble universe and ignored Einstein's theory of relativity. Scientists are now tackling the black hole information with a new approach called many worlds idea. Who knows, black holes just might be the key to answer our questions about the existence of parallel worlds. And that's it for this video. Comment down what your thoughts are about this very complex matter on parallel universes, and also let us know what other confusing space facts you'd want to explore with us. We will see you in the next video.